Okay. So, Bernoulli trials. There are two possible outcomes. Success, which we label with a P, and failure, which we label with a Q. Q is equal to 1 minus P. The probability of success.
Is it 1 minus P or L?
1. Probability of success always stays the same.
Did you say
No, it's 1.
1. And then trials are independent.
I should know that because you do your L's differently when it's an equation.
Wee.
But I just thought maybe she tricked up this time.
It's okay. I probably threw off Sarah and Melcher last class because I kept doing local, like writing the word local, which has 2 L's. I would write one of them curly and one of them just like a straight line. So people like don't like my 2's either because my 2's sometimes I put a little bloop-de-doop in it and then sometimes it's just like doop.
You were like, it's a loop-de-doop.
I thought you were talking about that, Sarah, and I was like, what the heck? I don't remember this in
Oh, no.
Same. Same.
Other Sarah.
Other Sarah, yeah. How many Sarahs do we have?
2.
2?
Well, I mean, there's some in like the little ones,
Those
but.
ones aren't, they don't count. They don't count right now. They can count later.
All right, examples of Bernoulli trials. Flipping a coin.
Ugh.
What?
Flipping the coin. That's such a dumb way to choose things.
Tell me about it. Football.
I hate football. I don't understand.
You weren't
it.
very happy about the Super Bowl, were you?
No, not that. It's the overtime for football. The fact that it is decided literally by a coin flip, I have a problem with.
Really?
Basically, the first team to possess the ball, if they score a touchdown, the game is over. The other team doesn't even get a chance in overtime.
That's stupid.
If they score a field goal, the other team does get a chance. After the first team has possessed the ball, the next score wins. Or if there's a defensive score on the first team's possession, then the game is over. So, there have been multiple times where the team that's the first one to possess the ball has scored, meaning the other team doesn't have a chance. I just don't think that's right.
Yeah.
But nobody cares what I think.
Imagine. Yeah. Right? Imagine going into an overtime and then I can imagine like the feeling of like your heart just dropping when you don't have the ball. That'd be so sad.
It's so sad. Came back to bite one of them recently, though. They threw an interception. The game was over. It's great.
I like
All right.
basketball better.
Well, I'm glad you said that. That leads into the next example.
Oh my gosh.
Free throws in basketball.
No. I don't like free throws. I miss them.
Let's see. Melcher, are you the best free throw shooter on your team?
I don't know.
You're the only person I ever see consistently make them. That's why I was asking.
It used to never be like that.
There was one game I was in there and I was like, you were like, swish, 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 swish. And I was like, oh my. I was like, we could do a stats problem off his free throw percentage.
I think I might be our best free throw shooter on the girls' team. Between me and Amy.
I was thinking that I've seen you shoot more than her, I think.
Yeah. I get fouled. I get fouled a lot, but they never call things on me because I'm tall.
That's what one of my girls
They
the other
don't
day,
think that
I'm not
tall
joking,
people
the girl
get
came up and was like, wham! And they didn't call the foul, and I was like... And then one of
I
my
made the
girls
same
to the
face.
girl on the other team, she comes up and I was like, all right, look. I was like, when they foul out, I was like, you're going in. I was like, play really tight defense. If you bump them a little bit, that's okay. Don't, like, intentionally hurt them. So what did she come out and do? She kind of pushed him over, and then she was like, wham! She, like, threw an elbow, and I was like, you can't do that! Then the ref's like, Coach, I should give her a technical. And I was like, and? I was like, you're not calling anything for us, so might as well. Anyways, it was just very annoying. But I was like, those refs we had the other day.
I have the same.
Really
I have the
irritating.
same face whenever they don't call off. I'm like, every single time. It's just. I get so mad.
Nathan, when like, anytime he goes up, he go, hey! Like, anytime he goes up and he goes, hey! Like, he just, like, yells, hey. Like, I don't.
Thank you. That was
like,
such
try
an
to
important
get the
story.
attention of the. Well, because we were talking about, like, things that you do.
No, it was just very anticlimactic. I know.
Well,
Hey!
Hey!
this
That's
is-
it. I was like,
Okay. What do you mean? What do you mean?
No, like, he goes up and he's like, hey! Like, I
When he
don't.
shoots,
No, like, if he goes for a layup, and then, you know how, like, Javon flops?
he does.
Feel
fall,
like-
yes.
Yeah, yeah, or like that. Nathan just straight up goes, hey! Like,
And then just continues to.
yeah. Like, he would go up for a layup and be like, hey! And then
I think that's really funny.
fall over it. And I just
Oh
look
no, I
at
was like,
him.
my thing is frozen.
But I think
We're
it's
good.
funny, and so I die laughing every time he does it.
No, okay, I didn't understand. I thought you meant when he went to go
Mega
go
boards
three.
Free throw. Then he'd just be like, hey!
Hey.
And then, see, like, Nathan, like, make a face like playing.
Holly was like,
He goes,
what,
"Hey."
Holly, we were practicing free throws, and Holly was like, I need to do my stretch. She just, I don't know. She was like, I'm gonna start doing a stretch every time before I shoot, and she was like, making them, and I was like, what is
Whatever
this?
works, you know?
Okay, I guess routine, but.
All right. Another example is for looking for a defective product on an assembly line.
He was Band-Aid.
Possibly. Taylor.
Big. I thought that was a Band-Aid.
I was gonna say another example is Pass the Pigs, but okay.
Oh, we doing Pass the Pigs today?
Not today, but it's like, Melcher, what kind of Band-Aid do you want?
Like
I got some like Whopper Band-Aids.
I just need one for my finger because I like started bleeding profusely out of my finger
That's-
during the game.
That doesn't sound
It
good.
was just a- it was just
Well,
small.
so like I know what size you need. I've got like
Oh
a
my gosh,
million
it landed.
sizes.
Well, I just,
Why did
I
you
don't
get
know,
so
just-
scared of it? Like, why did
I
you
was
catch it?
scared.
and,
I thought it was a
throw
Band-Aid,
down?
and I was
like, this is a big Band-Aid. And then I was like,
She caught a Band-Aid. I thought it was holding Band-Aids in
like,
it. I was like,
screamed and put it down. I was like,
Dang.
I was like, I was gonna toss Taylor a pig, and then she was like, ah!
wait, for the record, I threw it up, it hit a few desks, and look how it landed.
Anybody else want to catch a pig?
I want to catch a pig. Well, I didn't.
Hey, and mine landed correctly. Look at that.
Why does it feel like that? I don't know what I was expecting.
See?
And I got some party pigs.
Yeah, party pigs.
What's
What
up
do they
with
look
that
like?
pig?
We're
Why
gonna
don't
play
they have
some
cats?
pigs one day.
I like this pig. It's giant and it feels weird.
It's like almost
I
like
wasn't
a
expecting
squishy,
it
but
to
it's
feel
not
like this. I thought it was gonna be like
Hard.
no, like you know,
like
there's
plastic.
like nothing
I thought it
in
was
the
gonna
inside.
be
Like
plastic.
you know, like
or
I didn't
hollow.
think there was gonna be anything. Yeah, hollow. That's
Like a
right.
plastic hollow thing.
But it's
Well,
not.
You're gonna lose.
Bacon.
Wait, we were watching a pig race at it was at a festival or something for a field trip, and when the really fat pigs
It
came
looks
out,
really
Brooke yelled,
scary.
"Bacon!" in front of everybody, and I was like,
Love
oh
that.
my
Do
God.
y'all remember when we used to do the pig races here at school?
Yes.
That was so great. We should do that again. We should do a pep rally again. We haven't had one of those in like 10 years.
I know. Or
Oh,
after
Rallies
parties
are
at, for home.
Yeah, we've always done them for basketball because we always did it the week of homecoming.
Oh, okay.
I want to go to a pep rally. That seems like such a high school thing.
It is. It's so sad that we don't do them.
Let's arrange it.
Yeah, we got
Not
to
the
high
junior
school and they
class, though.
stopped, guys.
Junior class is not doing that. But
All right.
somebody should arrange it.
Geometric model. Modeling the number of Bernoulli trials
That's so funny.
until the first success.
Oh, Bernoulli is capitalized.
It's a guy.
That's a
Really?
guy? That sucks.
Poor guy, he has a crappy name.
Well, I think he's not from here, so
Uh,
that's probably why.
There was this person, I don't know if they're real, but their name was Mary, and I was like, that sucks. Like, I would not go outside if my name was Mary.
Who would do that to their kid?
Mary, quite contrary.
Maybe that's what
Not a real person.
Anyways,
Daniel Bernoulli was the nephew of Jacob, whom you saw in chapter 14. He was the first to work out the mathematics for what we now call the Bernoulli trials.
For the record, I
There's
don't
a
know who
picture
the
of him
guy
in your
was.
book.
Bernoulli
Oh, great. And he has crappy hair, too. Must have been made fun of every day of his life.
I have never, the only time that I think I've looked through our book was that first chapter when Mr. Cass was like, read the book.
Yeah,
I was like,
that's
okay.
the only time I read that book.
There's a comic, right? It says, "Oh, good, a true or false test," and then the next one. At last, some clarity. Every sentence is either pure sweet truth or a vile, contemptible lie. One or the other, nothing in between. And then you see the kid taking a coin and flipping it. Oh God, I love this stuff. This is like my favorite stuff to do in stats. It's great. All right, so we also have the 10% condition.
That's all we're writing for the geometric model. Oh, I'm going to write bigger then.
I didn't know that. Oh no, I wrote so small.
Yeah, you wrote
This next thing is 4 lines, in case anybody
It's
wants to
'cause you
know.
put a bullet point. If you didn't put a bullet point there, I would have thought that there was more.
I just, there's been bullet points for everything, so I just made a bullet. All right, 10% condition. In geometric models, technically, this is like the 10% condition goes under geometric models. It just needs to get shifted over a little bit. So, anyways, in geometric models, trials aren't independent. Since we are sampling without replacement, as long as our sample is less than 10% of the population, we can assume they are essentially independent. And you are going to need your calculators in a minute.
I feel like when I take stats in college, it's not going to be as fun as this. Because I don't, we have a pretty fun stats class. It's pretty exciting.
It's true.
But it won't be like that. And I don't like that.
Look like kind of need what's under the box. Okay, thank you.
Oh, sorry. I'm going to try to switch back and forth for colors here so I can show what we're doing and then also in a different color show how to do it on the calculator because kind of an important thingy.
That's true.
So. All right. Suppose a computer manufacturer rejects 2% of the chips produced because they fail pre-sale testing. What's the probability that the 5th chip is the first bad one you find?
I hate that. Ew.
So the probability of bad
0.2.
is 0.02. Trials aren't independent. Because we're not putting the one back in that we just took out. 5 chips is less than 10% of all chips manufactured. Some of this is just doing some deductive reasoning.
I thought it said
It kind of does look like that, you know. Looks like load a little bit.
Oh,
What?
I
It looks
wrote
like
load.
load instead of bode. I mean, bad. Oh. I stopped writing. I said of all chips, man, and I looked up because they were like it looked like load. So then I looked up and I looked back down. I was like, all chips, man. What does that mean? Really confused. Figured it out though. Don't worry.
All right, so I'm gonna leave some space over here to the right to write. How to do it in the calculator on the left-hand side. I'm gonna show you what to do in general. So if you just wanted to do this by hand, and I'll show you that both ways give you the same answer. So the probability for x being equal to 5. Okay, we want that the 5th chip is the first bad one. Okay, bad is 2%. So how many, like, what percent are good?
0.98.
0.98, and there's 4 of those, so 0.98 to the 4th times then that the 5th one is bad, 0.02 is equal to what decimal?
That's fine.
Where did we get 0.98 from?
That's how much is correct.
How much is good?
So 0.02 is wrong then. That means that.
Oh, God.
So 2% are bad, so 98% are good, in theory.
I have 0.018.
Wait, so you just type. Wait a minute. How'd you do this?
So then I'm going to write what we're looking for, the function we're looking for on your calculator. Pdf. P comma N. So on that, okay. Let me see if I can do this. Ooh. Oh, that would be my foot. Okay. Whee! Clear that. Okay, so we're looking for geometric. Oh, did that get worse or better? Ooh, there we go. All right, so geometric PDF, so you're going to hit second and then vars. Okay, and then if you arrow, I would arrow up because you'll get there faster. You're looking for geometric PDF, so it's option E. Hit enter. It's asking you for a P and an X value. Okay, so P is the probability of the bad one, okay, so the probability that we're given, and then the X value is the number of trials we're running, so this is going to be 0.02 and 5. Then you're just going to paste that down,
No, whoa.
and it gives you the 0.018.
Okay, my foot's cramping. It doesn't feel very good.
Oh, that was not what I was looking for. There's what I was looking for. So this would be then of geometric PDF of 0.02 and 5, and that's going to give you 0.018.
we used this last thing, right? Last chapter.
Possibly, yeah. So then the next one, what's the probability that you find a bad one in the first 10 that you examine?
It's not the same, right? Because it's within the first.
Yeah, so within the first, okay, means that this one is more for like when order is mattering. Actually, let me see if I can find in my actual notes here the official definition, just so that you have it.
I'm getting my other this time.
Okay, I'm going to try to write this down here at the very bottom, just since y'all don't have this. Come back. Okay. So, geometric PDF is for an individual outcome. We also have a geometric CDF. So that was the option below PDF on your calculator. That one is cumulative.
So that's what we're going to use for the next one.
So what that means is success on or before the xth trial. So x just being whatever value you're given. Thanks.
I don't know. I just
I
say
feel
that.
like if Mario sneezed, he'd come like that. I'm not sure if that's offensive. Is that offensive to you?
No.
That's good.
I don't get offended very easily though.
Okay,
so.
well, I just wanted to make sure. Because, like, I don't know how people would take being called Mario.
Yahoo!
Oh, alright, well, maybe you should start taking it wrong. Oh, that
All right. What's the probability that you find a bad one within the first 10 you examine? So we're looking for a probability that x occurs between 1 and 10. So 1 less than or equal to x less than or equal to 10.
so sad. I didn't. Okay.
What?
Can you say what it like in words what that is?
The probability that it's between 1 and 10, that the first bad one is somewhere in the first 10.
I was gonna do x comma 1 through 10. To be honest, like.
I mean, in a sense, as long as you know what it means, but this is officially the way to write it. And then you're going to probably want a whole line to write this next thing we're writing for if you wanted to actually do this by hand, and then why you're going to be very thankful that you have a calculator after that. So,
Doing it by hand first.
yeah. So the probability that the first one you get is, yes, sure.
Oh, is this gonna be like?
The first one you get is bad. It would be 0.02 plus the probability that the first one you get is good and then the second one is bad is 0.98
Oh.
raised to the first times 0.02 raised to the first plus then the next one, the probability that you have two good ones and then a bad one, 0.98 to the second times 0.02 plus, I'm assuming you're starting to see the pattern, so ... plus all the way out to the last one of 9, the first 9 being good and the 10th one being bad, 0.98 to the 9th times 0.02. And at this point, this is where you say thank you to whoever invented the calculator.
Yes, they're very good.
Or specifically that function on the calculator. Because That would be brutal to do by hand because we only did it for 1 through 3 and 10. So we didn't do it for 4, 5, 6, 7, 8, or 9 by technicality. We didn't write them all down.
Why is the .02 the second one raised?
Technically, they're all raised to the first because there's only one bad one.
Okay, I'm gonna try to figure this out before you try to tell us how to do it. I'm gonna try.
So you don't have to write to the one?
Correct. You don't have to have the one. I just was doing it just to show what you're looking for.
Can I say that the answer is .18 and be correct?
You can say that.
Is it correct though? No?
You'll see in a second. All right, so geometric CDF for .02, and then the number of trials is 10.
Oh yeah, that's good. I definitely got that one right.
So that's gonna be 0.18. Okay, and another way to think about this is 1 minus. Oops. One minus the probability of no bad in the 10
No bad.
would be another way to find it
Okay.
if you wanted to go back and throw it back to last section. But I would use the words, the stuff that's in green, and use your calculator.
Is it a coincidence that the A and B are kind of the same except for like the placement?
Yeah,
is it
purely a coincidence. It's not always going to be like
okay,
that.
is it just because it's 5 and 10? So it's gonna
Basically,
be
yeah.
like that? Okay.
Essentially, yeah. You okay over there, buddy?
Yeah, I'm just really sore like everywhere.
Oh. Gotcha.
Like not hard.
I'm gonna be sore tomorrow. I can feel it on my bones.
Oh my
So,
gosh.
how was choir today, guys? What did we do?
How's what?
Choir. What did
We finished. People get ready.
you do? Really? What did you do Thursday and Friday?
For song. The same song?
Oh,
Nothing new.
yes.
We have a quiz on Friday now.
Oh, dear. Ah! Oh, I got it. Never
Oh, I
mind.
have to do that.
We Gucci.
That's so weird.
Apparently their ears fall off really easily. Not really sure why or how, but that's what I read.
How?
Okay, I don't like the flimsiness by its neck.
The,
I don't know.
The,
Like, it's...
That's how the little pigs are too.
Ew.
Oh, don't fall off. Don't fall off. Whew. Okay. That was a struggle.
Are those the party pigs?
These are the party pigs.
Party pig.
Though those seem like more of a party pig than these ones.
I know, right? They're so big.
These ones have little like udders on the bottom of
Will
them.
it stay in the balloons if I throw it in the balloons?
Try it.
Can I
Throw
try?
'em in.
I want to see if it's good to stay.
See, baby piggies.
Baby piggies. I remember we played with
When
those.
pigs fly. Oh my gosh, pigs are gonna fly. All those people who are like,
I don't stop it. You're gonna throw it.
Here, you have to throw it in.
how am I
Oh
supposed
gosh.
to? Oh, pigs-
Negative.
Pigs do not.
But
fly.
you got a cider.
Yeah, it either lands like this, it can land like.
See? Land on its side.
Okay.
You got 5 points.
Oh, I got another.
Whee!
What's that?
Ooh, you got a razorback.
I'll hear my knee just pop.
All right.
Anyways.
Oh, in honor of the Olympics, we have an Olympic archer. I know it's like Winter Olympics, but like whatever.
Winter Olympics are more
No,
exciting.
here.
Well, actually, I don't know which one's more exciting.
I don't know either. I like certain aspects of both.
I like the figure skating. It's really pretty.
Me too.
I like to watch it.
Okay. An Olympic archer is able to hit the bullseye 80% of the time. Assume each shot is independent. If
80%?
So I looked at my
That's
paper
so
and I was
good.
like, whoa, I have
if she shoots 6 arrows, what's the probability of each of the following results? A. Her first bullseye comes on the 3rd arrow.
Okay. I got this. So what you do is P bullseye or something. I don't know. We're gonna do that. Equals. Okay, that's the same thing. Px equals 3 is actually what I meant to say. I just stumbled on my words a little bit. And so basically what you're gonna do is you're gonna do geomet
Come on, you got it.
PDF, and it's gonna be 0.8,
Isn't it?
and then
Oh, wait a minute.
times 3.
Isn't it point 2?
Am I right?
Point 2.
No, because we're looking for a bullseye now.
So we're looking for the good one.
So 0.8 coming on the third toss. Okay, if you wanted to actually see this written out mathematically,
Smart.
2 misses initially, so 0.2 chance of a miss squared times then the probability of a make on the third. Okay, that would be if you wanted to do it without the fancy calculator option.
I like
Okay.
fancy calculator
Me
option,
too.
To be honest, makes me happy.
What does the fancy calculator option
Zero,
give us?
3, 2. I wrote kind of quick.
Okay, so we also have a binomial model. Okay. Here, we're gonna do this because I need to write something down. You can probably write it on the side of what you're doing. I just okay. For a binomial model,
Oh. Are we in the notes section now?
I just switch over to notes for a second to write down because I don't have enough room to write. Like how I wrote geometric at the bottom, there's a few extra things that go with binomial, so I'm just
Just writing it on the top.
writing this. If you have room, like, yeah, you can write it on the top. It'll probably fit there. Anyways. All right. Okay, this calculates the number of successes among a fixed number of trials. Okay, it still requires Bernoulli trials, so that doesn't change. Okay, the parameters, okay, there's 2 parameters for this. Okay, P is still the probability of success, just like we had written on the first page.
Did we have a history thing
Quiz
on
today?
Friday?
No, it's today.
For real?
Yep. Today.
N is the number of trials. And then X is the number of successes.
Is it a test or a quiz?
Quiz.
Oh, okay.
In trials.
Oh, good.
Let's read all your notes.
Oh,
There's 43 slides.
well, guess what, guys? I was not in class.
Yeah, so you're learning them. Oh, she posted them. She posted 43 slides.
Okay, so like geometric, how we have a PDF and a CDF for that, we also have a binomial PDF and CDF. It's the same, where you get it on the calculator, is the same spot. So the binomial, it's called Binomial Pdf. Okay, this one, and it would be in the form, in case you're doing it, of N, then P, then X. Okay, where again, X is the desired number of successes. Okay, just, it's basically what's written there, but just so you know. PDF is still for an individual outcome. Okay, with exactly X successes. And then the CDF one, so binomial CDF, is still in the form NPX, but the difference is that this one calculates X or fewer successes in N trials.
No, my other foot's cramped.
Okay, and then tomorrow, or here, one other thing I just want to note right here is watch out for
Looking for
at least X. Okay, if you see that, use the complement rule of 1 minus the binomial CDF. Okay, because otherwise you're going to end up having a problem. Okay, or well, I guess this could also be PDF depending on what it's asking you about, so just FYI. The difference is that this one is NP and then X minus 1 instead of X. So.